This is Free Range Digital Design Foundation Modeling. This is Chapter 7, second lecture. So this chapter is all about timing diagrams. We introduced them in the last lecture, and now we want to start talking about timing diagram annotation. So as a quick review, timing diagrams, they're used to show the value of signals or the signal as a function of time. So vertical axis is going to be the signal values. The horizontal axis is going to represent time. Three main purposes of timing diagrams is to describe, verify, and document digital circuits. So timing diagram annotations are very important simply because timing diagrams are not that easy to read. So what you want to do is draw the reader's eye to what you're trying to show them. You use annotations to highlight the important stuff in your timing diagrams. As you'll find out, timing diagrams get really busy, really fast, and they get hard to read. A few annotations is going to make it much more readable. When you're doing a timing diagram, these are some of the things you always do in timing diagrams. You always put a descriptive title on it, not timing diagram. Timing diagram doesn't mean anything. Say, timing diagram showing the operation of blah 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 circuit. Also, when you're generating a timing diagram, typically the tools will very easily generate lots and lots of signals. What you want to do is not include the irrelevant signals. You only want to include the signals in your timing diagram that are important to you. Don't include everything. Also, you have generally the tools give you the ability to zoom in or zoom out. What you want to do is fill up the entire page with the timing diagram that has the information you're trying to show. Don't try to stuff too much onto one page. It makes it sometimes part of the signal values become unreadable. What you want to do is show a reasonable amount of information in a clear way. Don't stuff it into one corner of the page. Don't try to include too much information. Golden rule of timing diagrams is to show what you need to show as simply as possible. And so you don't want to try to show too much or zoom too far out, etc., etc. But there are a couple guidelines that I follow when I'm doing timing diagrams, and I try to get my students to do this also. So timing diagrams show whatever you need to show on them, but I'm trying to group these into three specific things that they show. So one is the temporality of events, one is causality of a signal, meaning what caused a signal to switch, and the other one is correctness of operation. So your timing diagram is showing that your circuit is operating properly. Temporality of events simply means you're showing how much time something required. So this is timing diagram showing two signals. Signals are irrelevant, but what I have here on the bottom is I've marked off how the length of certain signals, and I've listed that time span. I listed the time of that certain event on the bottom. So whatever you need to do here, I put a note under these as well as the timing value. I've got these arrows that clearly delineate the time span, and I'm not sure what else to say about this. Well, show what you need to show. The second thing timing diagrams typically show is the causality of events. So this is a specific type of approach to show that causality, and so this happens to be a counter, up-down counter. You can see this up signal allows the counter or the output to go up or down. Kind of immaterial for this problem, but the issue is that what this arrow is showing is that on that rising clock edge, due to the fact that this signal is a low, it's going to count down. So this arrow here is showing the causality. I'm using these two dots here to show that it's these two events or signal values that cause that transition to happen on this count output. So there's lots of ways to do this. This is, I think, the most clear way. You can see it's simply I'm using the same annotations throughout this, and once again this causality event. So what caused this event to happen, which is the switching of the output. So the last timing diagram annotation that is common out there is you're using your timing diagrams to show that your circuit is operating properly. This is kind of arbitrary. This timing diagram would be the output of some type of adder. So what I'm doing here in these notes is showing that adder is in fact working properly. So I set up an example calculation there, and then I did the calculation directly. So I use these arrows to point to where I'm getting these values from. I think it shows pretty clearly that circuit is operating properly if it is in fact some type of adder. Now this is arbitrary, this works, I use it quite often. If you have a better idea or a clearer idea, by all means use it. Now typically you don't have to mark everything. If you have a big file and that's doing adding of different number values, you don't have to typically put an annotation for each of these. Put as many as you want to make it clear. So once again, this is another type of annotation similar to this, showing the correctness of operation. Just trying to get creative in how I demonstrate that the thing is working properly. Once again, if you have better ideas, by all means use them.